Assalamualaikum and very good day to Dr. Asma. My name is Nurhaiti binti Halim. My number is 836783. And on behalf of my group members, I will opening our presentation for subject SQQM5013 Risk Analysis. And project title are Evaluating the Risk of Petrol Price Volatility on Transportation and Logistic Costs in Malaysia. Okay, to kick things off, let's look at our introduction slide. As shown here, petrol price volatility refers to the unpredictable changes in fuel prices driven by global supply demand, geopolitical issues, and economic uncertainty. So, in transportation and logistics, fuel is one of the most critical cost components. So, any increase in prices directly expand logistic operating costs, heavily impacted three areas, which is the first one is our freight cost, distribution cost, and overall supply chain efficiency. So in Malaysia, because our logistics sector is highly dependent on road transport, we are deeply exposed to these global fluctuations. Okay, right now, so let's move to the problem statement. The real issue here is how fuel shocks create a domino effect. So, the firstly is a cost uncertainty is immediately squeezing operational margins. And this will trigger cascading effects that drive up costs in warehousing and inventory. And compounding, this is Malaysia's high market dependence on global oil prices, which threatens long-term stability. Ultimately, this leaves us with a major research gap, as we currently lack firm-level empirical data to measure these specific metrics. Okay, next, moving on to our objective. Our research is structured as a complete risk management process. We have four objectives. So, firstly, we want to identify the key operational and financial risks. Secondly, we aim to assess their likelihood and impact, including the development of a risk metric and risk assessment chart. And thirdly, we will quantify the exact financial exposure using several quantitative methods such as value at risk. And finally, the last one, we propose a targeted mitigation strategies to cushion these fuel shocks. Okay, now, to keep this process highly precise, our scope is strictly bounded to road transportation within Malaysia, and we focus directly on local cost metrics like warehousing and distribution, while explicitly excluding aviation, marine fuel, and international logistic networks. That concludes the foundation framework of our study. I will now hand over the presentation to my next group member to discuss our literature review.
My name is Siti Sarah binti Muhammad Afandi, and I will be presenting the literature review for our study. This slide summarizes the key findings from the most relevant studies review in our literature. First, Al-Masriya 2024 found that petrol price volatility is mainly influenced by global oil market conditions, exchange rates, geopolitical events, and government fuel policies. This helps us understand the main driver of fuel price fluctuations. Next, Duta 2024 reported that rising fuel prices significantly increase transportation and logistic costs, affecting operational efficiency and overall business performance. In the Malaysian context, Ying and Harun 2019 highlighted that the transportation sector is highly vulnerable to fuel price increases because of its heavy dependence on petroleum products. This provides local evidence supporting our studies. Regarding risk assessment methods, Lasota 2024 and Han and Wang 2021 show that qualitative tools such as risk metric can effectively identify and prioritize risks, while quantitative techniques such as sensitivity analysis, scenario analysis, value at risk VAR, and conditional value at risk CVAR can measure financial exposure under different fuel price conditions. Finally, Wang 2020 suggested several mitigation strategies, including fuel hedging, supply diversification, and strategic planning to reduce the impact of fuel price volatility. And from this review, we identify an important research gap. Although many previous study have examined the economic and operational impact of fuel price volatility, very few study integrate both qualitative and quantitative risk assessment techniques into a single framework, particularly for the Malaysian transportation and logistics sector. So I will pass this slide to Nur Akila to present about qualitative risk analysis.
Next, I will cover the risk assessment of petrol price volatility on transportation and logistic costs, both the methodology behind it and what we found. Specifically, I will walk through on how we identified, score, and rank 8 operational and financial risks that logistic firms face when fuel prices swing. We use a qualitative risk assessment approach. The reason is simple. Petrol price swings not just raise fuel costs, they ripple outward into profit margins, supplier prices, delivery reliability, inventory costs, and cash flow. A qualitative approach lets us identify and classify all these risks and prioritize them. This follows standard risk management practice, which is identify risk, assign likelihood and impact, calculate risk score, risk classification, and risk prioritization, then rank them for mitigation. To do that, we use two tools, which are a risk matrix, which scores each risk on a 5 by 5 likelihood impact grid, and a risk assessment chart, which plots those scores so that the most urgent risks are easy to spot visually. Okay, based on that approach, we identified 8 risks tied to fuel price volatility. Risk 1 is the most direct one, which is an increase in fuel and transport costs. From there, it cascades. Risk 2 is reduction in profit margins because companies can always pass rising costs onto the customer immediately. Risk 3 is increase in supplier prices since suppliers face the same fuel pressure. Risk 4 is delivery delays from road changes. Risk 5 is a higher inventory replenishment cost, and risk 6 is inefficient transport mode selection, while risk 7 is inaccurate fuel price forecasting, and lastly is risk 8 is cash flow pressure from sudden price changes. These 8 cover the full range of operational and financial exposure. Okay, to compare these 8 risks fairly, we score each one. Likelihood is rated 1 to 5, impact is rated 1 to 5 as well, and multiplying them gives a risk score from 1 to 25. The higher the score, the more urgently it needs mitigation. We then group this score into 4 bands, which are 1 to 4 is a low risk, which means acceptable. We can just monitor it. 5 to 9 is medium. We need more some control measure. While 10 to 16 is high, which is we need active management. And 15 and 17 to 25 is extreme, which is that we need immediate mitigation. So here's what we found out when we actually score all 8 risks. They came out as an extreme, which is risk 1 with a score of 25, and risk 2 and risk 8 both at 20, and 4 came out as a high, which is risk 3, risk 4, risk 5, and risk 7, all scoring between 12 and 16, and 1 R6 came out as a medium at a score of 9. What notable is that not a single risk fell into a low category. That tells us petrol price volatility is not a minor, occasional concern for this industry. It is a substantial and ongoing exposure. This is the same data laid out on the risk matrix itself. Likelihood runs up the side, impacts runs along the bottom, and the color shows severity. Green is low, yellow is medium, orange is high, and red is extreme. You can see R1 sitting right in the top right corner, almost certain to happen, and severe impact when it does, which is why it scores a full 25. R2 and R8 is sit just next to it in the extreme zone, and the high risk cluster is R3, R4, R5, and R7 sits just below that. Nothing sits in the safe, which is green zone. based on the risk assessment chart visual, helps management to quickly identify which risks required immediate attention. If we zoom in on just the extreme zone, three risks stand out, which is R1. Risk 1, increase in fuel and transport costs, score the maximum possible, which is 25, because fuel is a direct, unavoidable input to transportation. There's no buffer there. While R2, which is risk 2, reduction in profit margins, and R8, which is risk 8, cash flow pressure, both score at 20. They are extreme for related reason, which is when fuel price spike, companies often can pass that cost onto the customer right away. So in short term, they absorb the hit. Margin shrinks and cash flow gets squeezed because any price adjustment or surcharge can kick in. So to bring this together, every single risk we assess landed in the medium and high or extreme zone. None were low, which is R1, R2, and R8 dominate the extreme zone, and they all trace back to the same root cause, which is fuel costs hitting operating expenses, margin, and cash flow almost simultaneously. Both the risk matrix and the risk assessment chart agree on this. The risk here is concentrated, not spread evenly across the board. Thank you. That's all from me. I'll pass to the next presenter.
Thank you, Akila. Next, I will present the results from the quantitative risk analysis. While we have identified what the risks are, this section will focus on measuring how much they will cost us numerically. So I am Tengku Noliana Nabila, matrix number 835612 as the first presenter. So our objective here is to convert those qualitative risks into measurable financial values. We use secondary data about the Malaysia fuel price from the Department of Statistics Malaysia (DOSM) and Global Oil Trends to evaluate cost variability and extreme risk. So this analysis will follow a six-step process starting from probability estimation all the way to the measuring the risk using conditional value and risk. So this will allow us to capture the impact of a price volatility under both normal and extreme market conditions. Okay, before we look at the risk, we must look at the data of the petrol price. As shown in this trend chart, fuel price in Malaysia were relatively stable between 2020 and 2023. So, however, a significant shift occurs starting in 2024. By 2026, we see diesel peaking at 6 ringgit 72 cent and 195 at 4 ringgit 27 cent. Since fuel can account for up to 50% of total logistic costs, the sharp increase in petrol price represents a systemic risk to the entire industry. So to quantify this, we calculated the expected monetary value (EMV) by converting our likelihood scores into probabilities and multiplying them by estimated costs. We found that the total expected loss exposure of 363,000. If you look at the bar chart on the next slides, you can see a clear concentration of risk. Our top three contributors are R1, the direct increase in fuel and transport costs, accounting for 90,000. This is followed by cash flow pressure R8 63,000 and profit margin reduction R2 56,000. Collectively, these three risks represent nearly 58% of our total financial exposure. This proves that petrol price volatility is the primary driver that increases financial risk in logistics sector. Thus, effective cost management is needed. By using sensitivity analysis, we also tested the sensitivity of our costs to the fuel price changes. Our finding is clear. For every 10% fuel price increase, the total logistic cost will increase by 5%. This is a high level of sensitivity. Furthermore, our analysis on percentage of fuel dependency or the beta value shows that the more a firm relies on fuel, the more vulnerable or sensitive they are to this shock. For example, a firm with a high dependency level sees a 7% cost jump for the same 10% of fuel price increase. To help management plan for the future, we model three scenarios. We use scenario analysis to evaluate the impact of different price scenario towards the logistic cost. So as you can see in this bar chart, the best case scenario where the price dropped by 10%, the cost will fall to 95,000. However, in the worst case scenario, which assume of 40% petrol price spike, the cost of the logistic and transportation will soar to 120,000. This analysis is a vital tool for management to prepare the what-if contingency plans for extreme market shock. So finally, we look at the extreme risk. Using the historical method on 463 weekly observation of the Malaysian petrol price, we calculated a value at risk and conditional value at risk. We found that the value at risk at 95% confidence level is equal to 2.53%. This means that 95% of the time, weekly price shocks do not exceed this threshold. However, the conditional value at risk of 5.2% is our most critical indicator. It tells us that during an actual market crisis, the average price jump is 5.2%. This is a severe impact that can instantly wipe out profit margins. With this number in mind, I will now hand over to the next presenter to discuss the strategies we can use to mitigate this risk. Thank you.
Thank you, Liana. Now, I will present the risk mitigation strategies. So, based on our qualitative and quantitative findings, we propose 5 key strategies that specifically tailored to address the risk identified in this study. So, the first strategy is digital technologies and route optimization. Since our sensitivity analysis showed that a 30% fuel price increase can raise logistic cost by 50%. Firms should invest in GPS tracking system, real-time monitoring tools, and route optimization software. These technologies help identify the most fuel-efficient routes, reduce unnecessary mileage, and also improve overall fleet utilization, where it resulting in lower fuel costs and better logistic performance. The second strategy is consolidation of shipment. By combining multiple smaller deliveries into larger single shipments, companies can significantly reduce transportation frequency and also total fuel usage. This is particularly effective during periods of high fuel price volatility as it cuts operational costs without requiring large capital investment. The third strategy is fleet modernization. Replacing all vehicles with fuel-efficient or alternative energy vehicles is a critical long-term investment. In Malaysia context, logistic companies can take advantage of government tax incentive, subsidies, and low-interest financing scheme to support this transition, where it ultimately lowering operating costs and improving long-term sustainability. The fourth strategy is strategy inventory management. Since fuel price changes directly affect inventory replenishment costs, firms should implement and advanced technologies such as demand forecasting, economy order quantity models adjusted for fluctuating logistic costs, and warehouse management system. This helps maintain optimal stock level while minimizing unnecessary storage and transportation expenses. Last but not least, the strategy is supplier and distribution network optimization. Our scenario analysis showed that under worst case condition, logistic costs could rise from 95,000 to 120,000. To build resilience, firms should diversify their supplier base, negotiate long-term procurement contracts, and establish distribution hubs closer to key markets. So this resulting in reducing transportation distance, delivery times, and overall logistic costs. So together, these 5 strategies address both short-term operational efficiency and also long-term structured resilience against fuel price volatility. So to conclude, the study set out to evaluate the risk of petrol price volatility on transportation and logistic costs in Malaysia. And the findings clearly confirm that this is not a minor operational concern but a significant and systematic threat to the industry. Through our integrated risk assessment framework combining qualitative and quantitative method, three critical findings emerge. First, the financial exposure is substantial. Our total EMV of 363,000, supported by a CIVA of 5.2%, demonstrate that fuel-related risks carry serious financial consequences, particularly R1, R2, and R8, which are all rated as extreme risk and together account for approximately 57.6% of total risk exposure. This means that increase in fuel costs, shrinking profit margins, and cash flow pressure are not just possibilities, but they are highly probable and financially damaging events. Second, fuel dependency is the core driver of vulnerability. Our sensitivity analysis shows that the higher a firm's reliance on fuel, the greater its exposure to cost shock. In a worst case scenario, logistic costs should surge up by up to 20%, a level that could seriously threaten the viability of smaller logistic operators who have limited capacity to absorb such increases. Third, short-term fix are not enough. While strategies like route optimization and shipment consolidation offer immediate relief, sustainable resilience require long-term structural changes, investment in fuel-efficient technology, multimodal transport networks, and digital logistics system, and also stronger government policy support. So, in summary, managing petrol price volatility is no longer optional for the Malaysian logistics sector. It demands proactive, data-driven risk management that address both expected losses and extreme market events simultaneously. So, for future research, we recommend extending this framework to aviation and marine fuel sectors, incorporating firm-level primary data for greater accuracy and conducting longitudinal studies to measure the real-world effectiveness of the proposed mitigation strategies. On behalf of our group, thank you for your time and attention.